Hello students, we'll be seeing software engineering introduction, the first chapter. So the subject software engineering deals with how an IT company actually works, or you can say how actually a software is being built. It's right from the starting, from the scratch, from the specifications or the requirements where you ask the clients, from there to the final project being delivered and also the maintenance of the software. So until these, all the processes we'll be seeing in software engineering. But before that, let us see what a software engineering is, or what actually a software is. So IEEE defines software as a collection of computer programs, procedures, rules, and associate documentation and data. So this is the definition of a software. So this is the most likely asked question for 2 marks. So to define an software, or how the IEEE defines an software. So if this is a software, then what is software engineering? Software engineering is nothing but it is defined as a systematic approach to the development, operation, maintenance, and retirement of the software. So as I told you, the whole process from where it is started up to the software becomes obsolete. Till then, whatever is happening in between, we call it as a software engineering. So then why this subject is needed, or why this software engineering, or why this software we are actually studying as a subject? So it's simply because to understand the problem. For example, for whatever the reason you are having a software to build, what is the reason for building the software? So mainly in some point or the other in your life, you come across some of the situations, and we call that as a problem in terms of a software for developing. So when you encounter that problem, you are trying to overcome that problem through developing a software. So this we call it as a software engineering, or this basic or the problem arises, we call it as a software problem, or the problem where we find that it is necessary to build a software for this problem. So what a software problem is, it is a problem is to systematically develop software to satisfy the needs of some users or clients. That is a problem we are having. So whatever the clients or the users come up with the problems, we help them to understand the problem and get the solution through software, and we are trying to give them solution through software. So what are the main problems that we encounter? It could be scale. What is scale? It is not possible to scale a software. See, if you say a software, we now know, at least you are studying in your final year, so you'll be knowing how a software is, like, the cost is measured for a software. How is it actually? If you say someone can even give a software for free, right? Some of the software is of course free, even though it has very good tools in it, or it helps you work in a better way, still they are free. And still some of the very small software which doesn't have much of the code or the programming, but still it costs. Why is it, or what makes it so? So it all depends on the humans who are developing it, as well as how the market is working. So scaling a software is a bit difficult. So we don't know how to scale, like how to actually measure if a software is of the good one or the bad one, or how to actually get the information of this. So that is one of the problem. Then quality and productivity. How well the software is working. What is the quality of the software? You cannot measure a quality of the software, can we? Most of the time, measuring a quality in one or the other thing is very difficult. Maybe in some of the chemical composition, maybe we can say the presence of such and such elements determines the quality. But when we speak about the software, how can we say a software is of high quality? So it's difficult. And next is consistency and repeatability. How consistent the software is, that is, whatever the information you give and whatever the information you get as the output, how consistent it is. That is, every time are you going to get the same result, or every time is the software going to give you the exact result that is actually um, the software is to be given. The software has to give you, whether it is always giving the better results. And repeatability. How whatever the repeating instructions you are giving, is the software working with the repeating instructions? Then change. See, we cannot have the software for a long time. You might know the basic, the lifetime of software is only about 6 months, and after that at least you have to upgrade the version, or even after 1 or 2 years the software itself becomes obsolete, or else you have to always add, upgrade or add some of the new features to the software. So these are the, some of the problem that the software problems that we face. So in this we have something called as software quality attributes. That is, we have the softwares, the the problems like quality and productivity. And to understand this quality, we need to have some of the quality attributes. That is, on what basis you are measuring the quality of the software. Okay, so there are 6 things. The first thing is functionality. What is functionality? It is nothing but the capability to provide functions which meet stated and implied needs when the software is used. So, whatever the client is asking, whether that functions are there in your software, that determines one of the quality, that is functionality. Reliability. You have studied what is reliability in your first semesters. So, what is reliability? It is nothing but how well you can rely on the information that the software gives you as a output. That is the capability to maintain a specified level of performance by the system or the software here. Next is the usability. What is usability? Again, we say it as a user friendly. That is the capability to be understood, learned, and used. That is usability. Efficiency, the capability to provide appropriate performance relative to the amount of resources used. That is efficiency. That is, in what amount of time you are supposed to get the result, and are you getting that result. See, if you get one result, maybe after an hour it is not efficient, right? Your system is not efficient. It has to give the results in a fraction of seconds. Only then we call it as an efficient system. So that is one of the example. There could be many, like maybe speed or the quality, whatever it is. So all this combined together, we can call it as a efficiency. Next is maintainability. You know what a maintainability means? It's like once you develop a software, it has to be maintained so that it can be used for longer years. So the software should be able to be maintained. See, hardware, it's easy, like maybe sometimes some of if you say computer hardware, you just need to clean the things and keep it nice and tidy. And if you say some of the machineries, what we do, we lubricate, right? Or we add some oil and keep it functioning, so that there are no sounds or vibrations that is happening when you're working on the machines. So in the same way, software, what it has to be, the new add-ons or the new features should be able to be added to the software, or else at least whatever the new things, the new technology comes in the market, that the software should be able to be modified with that new technology that is being in the market. So that is maintainability. Next is portability. That is, you cannot some of the softwares are there that is only designed for one system, but otherwise your software should work in multiple systems or multiple platforms. Only then you say a software is of a high quality. So this is some of the important software qualities, which is again important. Next is software engineering approach. What is this software engineering approach, or who are the key stakeholders in this? That is people, process, and technology. These are the 3 things that are very much important in software engineering approach. So we call it as an iron triangle. That is, quality and productivity depends on the technology, people, and the process. So these are 3 things that actually affects the quality and productivity of a system. So next comes a phase development process, requirement analysis, and so on, that we'll be seeing in the next video. Thank you.